Uh, Welcome back to class today. In our class today, we want to talk about Pythagoras theorem. Pythagoras theorem. Pythagoras is one of the mathematicians that propounded the law and the laws that we are using to solve a right angle triangle. So Pythagoras theorem states that if we have this addition of the square of the two adjacent sides will be equals to the square of the hypotenuse. The addition of the square of two adjacent sides will be equals to the hypotenuse. Why do we have it like that? So that's what we want to do today. We want to prove that theorem today before we go to application of Pythagoras theorem. So this is the theorem to use this triangle, and if you want to use Pythagoras theorem, it has to be a right angle triangle. So we use it only for the right angle triangle. And how do we identify that? We must have a perpendicular side, that is the vertical and horizontal must give us the perpendicular here, that's 90 degrees. Then we have what we call a right angle triangle. So this is a right angle triangle that I want us to use to prove this theorem, to prove this thing. If it's right or wrong, we are going to prove it now. So I have four identical, four of such right angle triangle. It's the same thing, don't forget. They are all the same size, same in length and everything, the same thing. Okay, so down here I'm having A, so all of it has A down here. So here is my C, all of it has C in the same place, and this side is my B, where we're going to have B across the four triangles. So we're going to use this four identical triangle to prove this theorem. Now that's what we want to do. That is real proof of Pythagoras theorem. Let's go now. Let's go. Now, so I'm proving now. This is the right angle I showed to you earlier. The right angle I showed to you, where we have our A, our B, and our C. Okay. Now I told you I have four of such identical triangle. Let me arrange it now. Let me arrange it. So if we have another one here, are you seeing it? We have another triangle here. Don't forget it's identical. It's the same thing in length. It's the same thing. Then we have another one like that. Do we see that? Let's move on. Let's see. We have another one of such triangle. Don't forget it's four. So we have another one up here. Okay. Do you see it now? Okay, we're almost done. Then we have another one, the fourth one. We have four triangle. We have another one here. Okay. Don't forget, I want to prove the theorem. What do we have here? Can you see what we have here? Can you tell me what we have here? We have a very big shape that gives us what? It looks like what? Fine, it looks like a square. Very good. The inside one look like what? We can see it. It looks like a square. But how do we know? Are we sure it's a square or not? No, we're not yet. Because in mathematics, you have to prove whatever you're talking about. You can't just assume that it's a square because it looks like a square. No, in mathematics, we didn't agree with that. We do not always agree with that. So let's look at it now. Let's look at the length of the side now. Though we can confirm maybe a square or not. Let me try and roll this place. Then we talk about what does it mean. What does it mean? From here to here now. What do we have here? What do we have here from here to here? Let's look at it. Don't forget how our triangle look like. Let me give you another very big one that we can use to explain that concept of the triangle that I'm talking about here. Look at this. This is the kind of triangle that we're having on the board. Do you see it now? So it's the same thing, just like the one that we have on the board now. We have our A, our B, and our C. Just like we have it here, A, B, C. This one is also A, B, C. We have our A, B, C, and A, B, C. Do you get it now? So our A is down here, our B is here, and our C is inside here. So if you look at what we have here now, all inside is C. This place is C. The slant one is C and C, as well as this place is also C. Do you get that? Do you get that? Be following with the mind on this one. No, we're not using this one. This is what we're going to use. Now, inside here. Okay, I want to talk about this side first. Now, look at it now. Assuming we have, let me use a very big one, so we can follow that big one there. Let me see if I have the big one that gave me correlation of what I want to show to you. Now, yes, this one will give me what I want to show to you. So we have a better understanding of the concept. So you can prove it anytime, any day. You can say that, okay, this is how Pythagoras got the theorem correct. Now look at it now. we have our B and our A, just like we have it here, A and B. So the length of this side, I hope you're seeing it from this big one. The length of this side is now A and B, which means we have to add it together. A plus B. Can you see that? A plus B. That's the length of this side now. This place as well, don't forget, it's identical triangle. So, which means what goes for one side will go for the other side. Look at this place now. This place too, just like when I have another one here of this one, it will be A and B. You see it now, A and B. I hope you can see it. Let me try if I can get it big quickly. Okay, there's a B, there's a B. Okay, don't worry, I will remove this one. I just want to use it to explain. That's why I do it very big. Now look at it now. We have our A and B. So to get the length of this place now, just like we have A and B in the small one here. So it has to be, let me remove this one off. It has to be A plus B. A plus B. Just like we have it here, A plus B here too. Do we see it now? So now we can now tell what shape is it now. That is how to prove that is a square. Is a square. So you cannot say it's a square without proof. So we can now see that this place is A plus B in the identical triangle that we have, and this place is also A plus B, which means we have the square like that. And we agree with that? Fine. Now let's look at the middle one. What is happening here? I have a shape for that one too. I have a shape. Let me put it. The shape. This is the shape. You see, just like a square. It's a square, right? Fine. It's a square. Very good. Let's put it in the middle. Middle of it. Middle of it like this. Fine. Can you see it now? Mashallah. We have the square inside as well. We have the square inside. How do we know it's a square? That's another point. How do we know it's a square? This length is C. So which means this place will be C. Isn't it? And this place is also C, which means we have the same length. And this place is also C, and this place will be C. Are we agree with that? Remember where we started from? Remember where we started from? From the triangle that we started from. Do we remember that? Do we remember the triangle that we started from? ABC, ABC. So which means the slant one is C. We have C, C, C. Are we agree with that? Shall we continue? Let's continue. Let's continue. That's very good. So we have the shape now. Fine. A complete shape. And when we want to find the area of a complete shape, are we going to consider the inside? No, because we want to find the area of the complete shape. Sure, we just like, it's a square. And area of a square is what? Area of a square is length times length, isn't it? Area of a square is what? Length times length. That's very good. So which means to find the area of the whole shape, we've started proving like that, but just let's take it one at a time. Then we're going to get to where we're going to see the real proof of it now. To get the area of everything now, that is the area of a square that we have there. Area will now be equals to, don't forget to talk is a square, right? We have this side times this side. Let's put this one at a time. For those that just join the class, so we have it A plus B. So we times it like that. Do we have it? Do we agree with this one? You see? Length times length, length times length. That's very good. Remember this one we have A plus B all in square. We still times each other like that. So now let me use the expansion form. We have A plus B, then A plus B. Let's finish this part before we move on to the other side that we want to use. So now if you want to expand, you know how to expand that. The first digit will multiply. We use the first digit here to multiply the two ends here, and we use the second one to multiply the two ends here, just like this. The A will multiply this, and it will multiply this. B will come and multiply this one, and it will multiply this one. When we get to the expansion and factorization, we're going to explain that one better. Now look at it now. Look at it. We have A times A. A times A as A square. A times B plus AB. B times A plus AB, still the same thing, and B times B plus B square. Do we see that? So we can add A plus AB plus AB. So we're going to have A square plus 2AB plus B square. Let's leave this one as it is. Let's leave this one as it is. Let's go back to the shape. Let's go back to the shape. Now, on the other side of it, we have how many shapes here now? How many shapes do we have there? Let's count it. We have one triangle, two triangle, the third one, the fourth one, and the what? And the square inside. Do we get that? And the square inside, which means we have the net of a triangle, the net of a square like that. We call it net. Do we get that? We call it net. So net of a square means when you split that square, that shape is a shape when you split it. And then how many shape comprise of that very particular shape? That is a net, the net of that square, of that shape. So the net of this one now, let me try and explain and put it on a separate something. Do we get this one? Can I open it up? Let me open it up. Now we have, let me first remove all the triangle that I'm having here. So the triangle, please don't forget how that one look like. I've already started removing it now. We have one triangle. Let me see. We have another triangle here. Another triangle. How many triangles do we pack together before? It's 4. That's very good. Don't forget it. It's 4. We have the third triangle. The third one. Fine. We have the fourth triangle. I told you is a net. So this is what we call a net of a shape. When you split it, you open it up. And what? Let me put it as it is here. And square. That's very good. And square. So now the net of the shape is now what? 4 triangle, 4 right angle triangle. Precise. 4 right angle triangle and a square. 4 right angle triangle and a square. Let's find the area of this net of everything that we have here. We want to find the area of this square plus the area of this plus the area of this. You know, when we had it together earlier, when we arrange it together, we have a whole shape. So now we want to also find the area of those shapes, everything together. So we have to add everything together. Okay? So area of the net now. Area will now be equals to area of this. Well, let me write this thing so you can see it very well. Area of this one, and the area of this square will be what? C times C. Isn't it? C times C. Length times length. C times C. Okay? So we have C times C, which will give us C square. Let's go like that straight. C square. Do we see that? Now, area of a triangle is what? Area of a triangle. Area of a triangle is what? Half base times height. Very good. Half base times height. And these are our base, these are our height, our A and B. Base height. Okay? Base height. So now, half base times height. But how many triangles are we talking about here? How many right angle triangle? 1, 2, 3, 4. That means we have 4 right angle triangle there. So let's say that. Okay, plus area of it, this one. We want to add it with the area of everything that we have done here. 4 right angle triangle. 4 times area of a triangle is what? Half base times height. 1/2 times A times B. Don't forget our base is A and height is B. Do we get it up to that place? Very good. So there is no magic. We didn't do magic. It's just a fun. Don't forget mathematics is fun. That's very good. Now look at it now. We have, we can simplify this one further anyway, isn't it? Now, which means 2 here, 1, 2 here, 2. Do we see that? Do we see that? So the next thing is C square plus, we have 2 that remain, don't forget, 2AB. A times B is AB. 2 times A times B, 2AB. Did you get that? 2AB. Fine. Now look at it now. When we consider the whole shape together without splitting it, we have this one. The time we split is when we get the nets, when we split everything, we have this one. So, and we are still talking of the same shape. That same square, we're still talking about that same square earlier, the same square that we started from. That same square that comprises of 4 right angle triangle and the square inside. Do we get that? Now, which means we're still talking of the same thing. This place is also the same thing as this, because it's this shape that we arrange together to get this, and it's that same shape that we split to get this. So which means this side must equals to this side. Do you get that? The two sides must equal to each other. Let me put it together now. Let me put it together. Should I put it down here? Okay. Let me see. Let me put it here. Let me put it here. So this place will equal to this place now. So we're going to have, what do we have here? A square plus 2ab plus b square will now be equals to what we have in this place. C square plus 2ab. I hope you are seeing it. Is it clear enough? Fine. Do you see it now? Now let's see. We have some common things there. So don't forget this one is also in square, as we have it here. We have 2ab here. We have 2ab here. We can collect the like term, isn't it? Like term. Let's collect the like term. We have 2a square plus b square. Let's take this one. This is plus. When it goes to the other side, you go and do what? Subtract. Is equals to c square plus 2ab minus 2ab. Do you get that? We'll try to simplify it so everybody can have a better understanding of it, okay? So now, this one we have, isn't it? This one we have. So what are we having? A square plus b square is equals to c square. So that is Pythagoras theorem. That's Pythagoras theorem. Do we see it now? So that's how to prove Pythagoras theorem. So take your time to study it. Inshallah, the next class we're going to talk about the application of Pythagoras theorem. Inshallah, okay? See you in the next class. Bye.